Hey guys, welcome back to Math Principles. Last couple of times we were together, we were talking about solving quadratic equations. Well, today what I want to talk about is graphing quadratic functions. Okay, so what we're going to do is use a graphing calculator at desmos.com. So there's a link on this assignment that you'll see. Go to www.desmos.com/calculator. You can either type that into your browser, or if you hover over it with your mouse, okay, see how my mouse is blinking? Press Control and then click on it. It should take you to the website. Okay, now here we are, desmos.com. Okay, now we want to come back and get this function that we want. Okay, we want type y equals a times the quantity x minus h quantity squared plus k in the function bar. Okay, now note, after we type that raising to the power of 2, we need to use that right arrow to exit the exponent. Okay, so come here, type y equals a times the quantity x minus h. Okay, get out of those parentheses. Do Shift 6 to get that caret. Now you can see right now it takes me up into the exponent. Now I want to get out of that exponent, so I'll use the right arrow, move over, and then I'll put plus k at the end. Now the next thing it says in these instructions here is to add slider. Okay, underneath that description, underneath that equation, we have the option to add a slider for h. Let's see, that should actually be a, h, k, or all is available. We want to select all. So come back to that to Desmos. Okay, and this one here that says all, that's the one that we want. Now it defaults all of these to 1. Okay, in the directions on this assignment, it tells us to slide the pins for h and k to 0. Okay, so let's come back here, and a we'll leave alone, but h is at 1, we'll slide it to 0. K is at 1, we'll slide it to 0. All right, so this is what we want. Now, come back to the assignment, and the assignment says copy and paste an image here and resize it to fit. Okay, well, all right, so if I come back to this one, if you had some trouble with this on the last assignments, there's a couple of tricks that we can use on Desmos that'll be a little bit easier for us. First, up here, okay, there's that share icon that allows us to share the graph. Click on that, okay, and we are going to export the image. Okay, now we don't actually have to download, we don't have to save, we don't have to go through all that. We can just right click on this image and copy this image. Okay, then we'll come back to the assignment and we'll paste. So Control V allows us to paste. Now you can see this image is really, really big. Okay, so note on the directions right here, it says resize to fit. So I'll click on this image, I'll grab one of these nodes on the corner, and I'll shrink it down. And I'll shrink it way down, okay, so that it fits in that box. And then we want to describe the shape that we see. Well, if you take a look at this graph, guys, and tell me what you think it looks like. I think it looks like a U. It's a U-shaped graph that opens upward. Now, what else do you think is important about it? Well, it's symmetric. If I look from left to right, it looks like the exact same graph. Okay, let's make this bigger so we can all see. Okay, if I look at this and I drew a line right down the middle, okay, that would reflect. Okay, so it looks like it's symmetric over the y-axis. Okay, and tell you what, let's move these all over and give them bullet points. Oop, we'll slide them back. There we go. Okay, it's metric over the y-axis. Now, the other thing that's really, really important about this graph is this point right here. Okay, this is what's called the vertex. Okay, the lowest point on the graph, or maybe the highest point on the graph. But what we see is it's where the graph turns around. Okay, that's called the vertex. Where this graph turns around, and on this one, that's at the point 0, 0. Okay, so we have a U-shaped graph that opens upward. It's a symmetric over the y-axis. Its vertex is 0, 0. And something else I want to bring to your attention, if we go back to the graph itself, okay, and we just click and drag, we move this upward, okay, we can keep sliding this graph downward, okay, and it's going to keep opening up. Okay, so it's never actually going to stop. Like all functions, this continues indefinitely. So it opens upward, symmetric over the y-axis, vertex is 0, 0, and it really continues upward forever. So I guess we could just say a U-shaped graph that opens upward indefinitely. Okay, and there we go. Now that's pretty much all we need. Okay, describe what the graph looks like. I think that's a pretty good description. If I told you draw a U-shaped graph that opens upward indefinitely, symmetric over the y-axis, and a vertex at 0, 0, I bet you would sketch something that looks pretty similar to this. Okay, now this is what's called the parent function. We're going to use this graph right here. This is going to be our basis for comparison for everything else that we're going to do on this assignment. Now, I'm going to help you get started on the very first one, and I want you to do the rest of them on your own. We're going to analyze this function, okay? And we're going to look at how this function, how the different constants in this function affect the shape of the graph. So this is our parent, this is our base, everything's all zeros and ones. We're going to look at what happens when we change some of those numbers. Okay, so for instance, here they want us to slide the pin for A to each of the following values, include an image for each, and describe how each graph is different from the parent function. So here they want us to show where A is greater than 1. So pick a number, any number, doesn't really matter. Okay, and let's make A greater than 1. I'm going to say, let's go up to 3. Now, what's happening as I make A bigger? And even if I make it bigger than that, let's say I go all the way up to 6. What happens as I make A bigger? Well, let's get a copy of this image. Okay, we'll right click on it, copy image. We'll come back to the assignment and we'll paste this into place. All right, we'll shrink it down. Okay, shrink it way down. And I don't need all those extra spaces here, so I'm going to delete a whole bunch. And I want to describe this change. I want to describe how this graph is different from the original. We'll take a close look at it, guys. The difference between those two is that this one is a whole lot thinner. Actually, I can describe the change. Oh, sorry. This graph is narrower. It's much more narrow than the original. Okay. Now, the next one, they want us to bring that A to something less than 0. Well, remember, numbers less than 0 are negative. So all I really need to do, okay, it was here at 1. I want to slide it down into the negatives. Oh, what happened? When I crossed over 0, well, at 0 it disappeared, but as soon as I got into those negatives, it flipped. Okay, so let's go with, say, less than 0. Let's just go with negative 2 will work. Okay, so as I flip this over, as I slide that A into the negatives, this gives me a flipped over graph. Okay, so that's what I want to put. So I'll go to share the image, export an image, right click on it, copy that image, go back to the assignment, okay, and I will right click in this space, or even just Control V, and that'll paste it. Now, again, the graph's a little too big, so I'll shrink it way down. So it's about the same size as the other one. I'll delete these extra blank lines, and I'll describe this change. So what happened when I changed that A into a negative is the graph flipped. It flipped over the x-axis. Okay, or I could even say, now it opens downward. Okay, so this is what we want to do. We want to look at what happens when we just put certain values in for each of those constants, because like we talked about with linear functions, y and x in these equations, those are the variables. But there's constants, and what those constants are, a, h, and k, are going to affect the overall shape of the graph. Okay, now we notice they're all still U-shaped graphs, okay, but this one's narrower, this one's flipped upside down. What about this? Okay, they want to talk about what happens when A is between -1 and 1. Okay, now what's really important, guys, we're not going to use 0, okay, but anything else between -1 and 1. So I'll tell you what, let's go with 0.2. Okay, if A is 0.2, that's between -1 and +1. Okay, let's click on that share, export image. We'll right click on that graph, copy that image, come back to the Word document, Control V, paste that image. All right, and we'll shrink it down too. Grab one of those nodes on the corner, shrink it down. And shrink it just a little bit more. There we go. Okay, and let's describe this change. Okay, well, it's positive, so it's not flipped over. But take a look at this graph and take a look at the original. Okay, this new one and the original. The difference between these two, okay, while this one was narrower, this graph is a whole lot wider. Okay, so that's what we're looking at. We're seeing how what A does to the graph. Okay, now one more thing we want to look at. We want to see what happens when A is -1. Okay, so, or it's going to be less than -1. So let's come back to this graph. Okay, let's make A something less than -1. Let's go all the way to -5. Okay, and let's look at this. Now this graph looks really narrow. So I'm going to share, export the image, right click on it, copy the image, come back to the Word document, Control V, paste that image. Now again, it's way too big. Grab one of those nodes and shrink it down. Okay, and think about how this graph is different from the original. Okay, look at this new one, look at the original. Okay, on this new one, the big difference, there's two big differences. One, it's flipped over the x-axis. Okay, it opens downward now. Okay, and the other big difference, it's much narrower. Okay, than the original. So how do we think that A affects the shape of the graph? Okay, well, if A is negative, the graph flips over the y-axis, or excuse me, over the x-axis. If A is a big number, the graph gets narrower. And if A is a fraction or decimal, or really just a number smaller than, or I should say between, -1 and 1, the graph gets wider. Okay, so these are the differences that we want to recognize. We're going to look at how that A changes the shape of the graph. Okay, it makes it narrower or wider. Okay, and even we could even just simplify that, just say it makes it narrower or wider. Okay, and then we can look at if it's a big, or excuse me, if it's a positive or negative, it could flip it over that y-axis. Okay, so these are the things that we want to take a look at. Okay, we want to adjust those values for each of those variables, look at how those different values change the shape of the whole graph. Okay, make sure that we're including an image of each graph and explain that change. Just a sentence or two, just a little bit of explanation of how that's different from the original. Okay, now remember, we're always comparing to the very original. This is always the one that we want to compare each of these graphs to. Now, last thing that we want to take a notice of, okay, when we get back to the next one, it says slide the pin back to A, for A back to 1 first. Then we're going to play around with H. Okay, so first, for each one of these, make sure we reset back to the original parent function, okay, and then we're going to check out those other variables. Okay, now guys, this is your assignment. This is what you're going to do. This is going to be due for tomorrow, so I want you guys to make sure that you're taking the time on Desmos to really, really adjust those different values. See what differences you can see. Recognize how those variables are going to affect the graph.